Now that we've completed the structural modeling, it's time to prepare our project for analysis. In this video, I'll guide you through ideCAD's analysis settings, where we'll define seismic parameters, site conditions, wind and thermal loads, diaphragm behavior, and more, all aligned with ASCE 7-16 and other international standards. We'll also review rebar selection and saving protocols, so everything is ready for a successful structural analysis. Now that we've created all the structural elements and floors, let's move on to the analysis settings. You can access the analysis settings by clicking the Analysis Settings icon located first in the Concrete tab. In the window that opens, under the General tab, you'll see the Project and Building Code Options section, which is where we enter data when the program is first opened. First, we will select the seismic forces calculation method, eccentricity method, and slab diaphragm modeling method. In modal analysis, select one of the seismic forces calculation method from the options. For eccentricity method, dynamic eccentricity, plus or minus 5% shift in mass centers, evaluated via dynamic analysis. Static eccentricity, eccentricity based on seismic loads at mass centers. Slab diaphragm modeling. You can choose between full rigid diaphragm, semi-rigid diaphragm, concentrate diaphragm masses. Applies total mass as a point at the diaphragm center of gravity. Use rigid diaphragm for vertical loads. If disabled, vertical loads are analyzed without diaphragm behavior. Use seismic combination in slab design. Include seismic effects in slab design and reinforcement. Consider in-plane forces for slab reinforcement. Accounts for axial forces in slab reinforcement design. In Option tab, we can open the wizard window by clicking on the Seismic Code Parameters wizard section. Site class selection. To begin, we select the site class based on the soil classification provided in the Site Investigation Report, using ASCE 7-16. If the site class is F, the required parameters must be entered manually from the Analysis Settings Response Spectrum tab in ideCAD. Risk category selection. Next, we determine the risk category of the building. This classification depends on how the building is used and the level of risk it poses to human life in case of damage. We follow ASCE 7-16 Table 1.5-1 for this step. In ideCAD, the risk category can be selected using the wizard tool. Coordinate and seismic spectrum information. At this point, we enter the geographic coordinates of the project site and the design spectrum parameters. You can also enter coordinates by selecting a place from the map that opens. These inputs are essential. Based on them, ideCAD automatically creates the horizontal design spectrum for the structure. Seismic design category. The program calculates the seismic design category automatically. This is based on the selected risk category, the short period spectral acceleration, SS, and the 1-second spectral acceleration, S1, values. This is done in accordance with ASCE 7-16. Story information and settings. Here, ideCAD will display the story settings defined earlier. If this is the first time you are setting up the project, and no stories have been added yet, you must enter them using the Story General Settings dialog. You can also edit existing stories at any time. Structural system type selection. Now we choose the appropriate structural system based on the design of the building. The available options are reinforced concrete, for buildings with RC columns or shear walls. Steel, for steel frame structures. Reinforced concrete plus steel, for mixed systems. Since we are designing a reinforced concrete structure, we choose reinforced concrete. Diaphragm type. At this step, we select the diaphragm behavior from the wizard. Rigid diaphragm. Semi-rigid diaphragm. Some structural system types may be auto-selected by ideCAD depending on previous choices, as required by ASCE 7-16. A semi-rigid diaphragm model was selected to achieve a more accurate structural analysis by accounting for slab deformations. Frame system classification and seismic parameters. ASCE 7-16 Table 12.2-1 to help classify the frame system. For both the X and Y directions, you need to assign response modification coefficient overstrength factor deflection amplification factor. Note, the table also includes limitations for building height and seismic design category, SDC, levels. We select the system suitable for the model from the list. We save the parameters we entered for our project by clicking the Save icon in the last summary section. We entered the settings in the Options tab from the Wizard section. Response spectrum settings. Wizard enabled, parameters autofilled. Manual entry, for codes where the wizard is disabled. Spectrum curve, preview generated from entered values. Staged construction settings, when the Use Staged Construction option is selected, stage-by-stage structural analysis can be performed. Within this tab, you can set the following. Story count in single stage, defines how many stories are constructed in each construction phase. Story construction duration, enter the construction time per story. First story loading time, T, time delay before proceeding to the next construction phase. If each story has a different construction time, enable. Use different construction durations for stories. This allows you to define individual construction durations for each story. Thermal load settings. In this section, you can define two temperature difference values, T1 and T2. If you want to assign different temperature values for each story, select Use temperature differences for stories. This enables you to assign T1 and T2 values separately for every floor. For wind load configuration, select Generate wind loads for sheetings based on TS498. This is used for wind actions on steel sheetings. Under TSEN January 4, 1991, additional options are available. Open structures such as scaffolding, transmission towers, etc. Tall structures, wind acts on diaphragms. Rectangular, mono/duo pitch roofs. Apply extra lateral wind loads to diaphragms. Adds wind loads directly to diaphragms in both X and Y directions as user-defined inputs. Foundation tab. Define ground and soil properties as follows. Dry soil unit weight. Saturated soil unit weight. Soil type, cohesionless, soft cohesive, hard cohesive. Coefficient of subgrade reaction. Foundation design geotechnical capacity. To analyze the foundation together with the upper structure, check. Include foundations in upper structure. You can choose one of the following interaction methods. Raft foundation, upper structure interaction. Direct connection. Enlarged connection area. Load safety tab. Set load factors for dead load, live load. Steel design options. You can configure bolt group analysis method, elastic or instantaneous center of rotation, weld analysis method. Choose based on design philosophy and joint type. Strengthening options. When planning structural strengthening, you can enter the relevant strengthening parameters here, to be used in performance-based design and evaluation. Other settings. Structured material naming and object naming options allow you to manage element IDs and formats. Check project consistency before report generation. If enabled, the software checks for code compliance and notifies users before generating reports. Under Environmental Exposure Class, you can assign the appropriate class per TSEN 206, depending on environmental conditions. This completes the analysis settings. Now let's select the reinforcement before the analysis. To access this command, go to the Analysis and Design tab, and under the Reinforcement heading, click Rebar Selection. With the Rebar Selection command, you can define which reinforcement diameters will be used in the concrete design. The diameters selected through this dialog will apply to all concrete elements, such as columns, beams, shear walls, slabs, foundations, piles, and retaining walls. First, click the tab of the concrete element for which you want to modify rebar options. Then, mark the reinforcement diameters you would like to include using the left mouse button. Only the selected rebar sizes will be used in the design. Unmarked bars will be excluded from the design process. You can also load region-specific rebar standards, such as SI rebars, US rebars, US metric rebars, Canadian rebars, Australian rebars. If needed, you can add a custom rebar by clicking Add New Custom Rebar. Enter the desired diameter and ID, and select a type. You can also delete selected rebars, or move them up and down in the list. This is how rebar selection can be performed. Let's save before analysis. To save your project in ideCAD, use the Save command. This command stores any changes made to your current project in the same file. If you've just started a new project, this is how you'll save it to your computer for the first time. To access the Save command, go to the ideCAD logo at the top left corner of the screen, in the ribbon menu. Click the logo, then choose Save from the drop-down menu. If it's the first time saving the project, a Save Project dialog will appear. From here, you can select the folder where you want to save it. Enter a name for your project in the File Name field. And click the Save button. From now on, as you continue working and enter new data, you can keep saving by clicking the Save icon again. Each time you do this, your project file is updated with the latest information. For quicker saving, you can also press Ctrl+S on your keyboard anytime. This ensures you never lose progress as you work in ideCAD. Thanks for watching. Don't forget to like, subscribe, and explore the knowledge base for more tips. See you in the following video.